Ever since deep learning just exploded onto the scene, AI has been moving at this incredible, almost unbelievable pace. It's reshaping pretty much everything, right? From how we work to just our day-to-day lives. But here's the thing. This global revolution isn't magic. It's built on a solid foundation of just brilliant academic research. Behind every large language model, every slick AI tool you use, and every bit of smart tech, there are a handful of really powerful, foundational ideas. And these aren't just small, incremental improvements. No way. These are landmark papers that completely change the direction of the entire field.
So in this explainer, we're going to break down the 10 most cited AI papers of the 21st century. Get this, each one has been cited over 100,000 times. That makes them the absolute bedrock of the AI knowledge pyramid. They're the invisible pillars holding up the tech we use every single day.
So here's the plan. We'll start with the top 3 heavyweights. These are the ones that unlock deeper networks and a totally new way of thinking about language. Then we'll hit the key milestones in computer vision and NLP. After that, we'll look at the essential tools and the one paper that kind of summed it all up. And finally, we'll see how it all fits together.
Okay, let's get right into it with the big 3. These papers didn't just contribute to the field, they fundamentally redefined what was even possible.
Topping our list, and the most cited AI paper of all time is ResNet. See, before 2016, there was this huge problem in AI. The thinking was, if you make a neural network deeper, it should get smarter, right? But in reality, they just got harder and harder to train. Performance would actually start to get worse. The entire field was hitting a wall.
The breakthrough was how ResNet solved this. It introduced this clever idea called residual learning, with what they called skip connections. The easiest way to think about it is like an express lane for data on a highway. Instead of forcing information through every single layer, these connections let it skip ahead, which makes it way easier for the network to learn. This one innovation let researchers build networks with over 150 layers, completely shattering the myth that depth had a limit.
Okay, so if ResNet is the architectural blueprint for these deep models, then our second paper, Atom, is the high-performance engine that actually makes them run. Training a massive neural network means constantly tweaking millions of parameters. Doing that efficiently is a huge challenge, and Atom was the solution.
Atom's impact was immediate. It cleverly blended the best parts of older optimization methods into one package that was robust and just plain easy to use. Suddenly, you could just plug it in and it worked fast. It became the default choice for pretty much everyone, and today it's the standard optimizer used to train all the massive models we see everywhere. Now, before we get to our third paper, let's set the stage, because this was a dramatic shift. For years, AI processed language sequentially, one word at a time, using models called RNNs. This was slow, it was clunky, and they really struggled to remember context over long sentences. A totally new approach was needed. And that new approach arrived in a paper with what might be the best title in AI history. Attention is all you need. This paper introduced the transformer architecture, a design so revolutionary it just threw out the old sequential approach completely. This isn't just an improvement. This is the engine that powers nearly every large language model today, including things like ChatGPT.
The core innovation here was the self-attention mechanism. It lets the model look at an entire sentence all at once and decide which other words are the most important for understanding the context of any single word. This gave models a true, deep understanding of language and kicked off the LLM revolution that we're all living in right now.
Okay, let's move on to our next section and see how all this builds. Here we're going to look at the papers that laid the groundwork for modern computer vision and then further revolutionized natural language processing.
The revolution in computer vision really started with AlexNet, our number 7 paper from 2012. This paper was like a seismic event. By using GPUs to train a deep convolutional neural network, it just demolished the competition in a major image recognition challenge. And that kicked off the modern deep learning craze. Then, just 2 years later, VGGNet, our number 5 paper, built on that success. It proved a simple but incredibly powerful principle. The key to better performance was making networks even deeper by stacking lots of small, efficient filters. And this timeline tells an incredible story. I mean, in just 4 years, the field went from AlexNet's 8 layers to VGG's 19, and then finally to the mind-boggling 152 layers that ResNet made possible. It was this explosive progression that completely transformed our ability to build powerful vision models. So if the Transformer paper gave us the engine, our number 6 paper, BERT, gave us the blueprint for how to use it.
It was published by Google back in 2018, and BERT basically took the raw power of the transformer and created a new standard for how machines could be taught to truly understand language.
BERT's key idea was simple but profound. To truly understand a word's meaning, you need to look at the context from both sides, from the left and the right. This bidirectional approach gave it a much richer understanding of language. It also cemented the pre-train and then fine-tune method that is now the dominant way we do things in NLP.
All right, now for something a little different. Coming in at number 4 is a classic, and it's not actually a deep learning paper. Random forests, from way back in 2001, introduced a powerful method that combines lots of simple decision trees to make really accurate predictions. And you know what? Even in the age of deep learning, it remains an incredibly effective and widely used algorithm for a huge range of tasks.
Okay, on to our final set of papers. These aren't just about new architectures, they're about the practical tools that brought AI to the masses and the definitive academic statement that cemented deep learning's place in history.
Here we have 2 immensely practical contributions. First at number 8 is UNet. It introduced this really elegant and powerful architecture for image segmentation. That's identifying specific objects in an image right down to the pixel. It became the gold standard, especially for things like medical imaging. Then at number 9, we have Scikit-learn. This paper introduced the Python library that, you could argue, democratized machine learning, giving everyone a suite of easy-to-use, powerful tools. And finally, at number 10, we have the Deep Learning Review paper. Now, this wasn't about a new algorithm. It was a comprehensive summary, published in the journal Nature by the 3 godfathers of AI, Yann LeCun, Yoshua Bengio, and Geoffrey Hinton. This paper was basically their declaration to the world that deep learning was here to stay.
The paper's real genius was in its synthesis. It laid out the history, it explained the core principles, and it highlighted exactly why this moment was different, connecting the dots between powerful GPUs, massive datasets, and new algorithms. By doing that, it legitimized the entire field for the scientific community and became the definitive reference for a whole new generation of researchers.
So, let's zoom out and put it all together. Because these 10 papers, they aren't just a list. They are an interconnected web of ideas that built the entire modern AI landscape.
And here it is. This is the pyramid they built together. You've got AlexNet kicking off the boom and Atom making it feasible to train these huge models. VGGNet and ResNet gave us incredible depth for computer vision, while the Transformer and BERT created a totally new paradigm for understanding language. And of course, tools like Scikit-learn put all this power into everyone's hands. Each paper was a crucial link in the chain, building on what came before it.
These 10 papers are the foundation, the absolute starting point for so much innovation. They answered the biggest questions of their time, which leaves us with a final thought. As AI keeps evolving at this breakneck speed, what's the fundamental problem that the next landmark paper is going to solve? And how is it going to change the world all over again?